Hey everyone, it's me, Miss B, and in this video we are looking at some practice using standard form, um, and this is for my Algebra 1 class. So, um, we learned today about how to use standard form and how to graph using the intercepts. So for part 1 here, at least for part A and part 1, we're going to determine the x and y intercept of the line described by this equation right here. So this one right here. And we can do that by plugging in 0 to actually find our different intercepts. So for the x-intercept, we're going to have a value for x and a 0 for y. And for the y-intercept, we're going to have the reverse. We're going to have a value for y and 0 for x. Now, as we go through this, as we plug in 0, what happens if we plug in 0 here for x? So let's just start with like the y-intercept. So I'll zoom in here, or we'll start with the x-intercept. If we were to plug in 0, 7 times 0 just is 0. So we would have negative 3x plus 0 equals negative 21. So effectively, in this situation, when we have something in standard form, plugging something in, or plugging a 0 in, just wipes out the term entirely. And we can imagine that our equation actually looks like this, and it's just negative 3x equals negative 21. It'll narrow it down to a one-step process where you would then divide both sides. In this case, we're going to divide both sides by negative 3. So I normally call this the cover-up method because I'm going to draw a little box here, but normally using my finger or something similar on my paper, but I'm going to use this, I would use this and then cover that up and then solve what remains. And solving for the next piece, I would cover up the other term and solve what remains. So if you hear me refer to it as the cover-up method, it's because I am literally covering one piece up to solve what remains. We just want to make sure that we don't cover up the sign that's in front of it, because that positive is important for the 7 and the negative is important for the 3x. So when we're covering it up, we are covering up the sign entirely to solve these. So plugging in 0 is effectively what we're doing for our cover-up method. So I'll actually show some work here, but later on I might actually just do my solutions that way. So this would be negative 3x plus 0 equals negative 21. So that's going to give us that x is equal to positive 7, because we would have negative 21 divided by negative 3. So we would have positive 7 here. And then for the second piece, to find the y-intercept, we would have 0 plus 7y equals negative 21. And when you divide both sides by positive 7, you get that y is equal to negative 3. So we'll put negative 3 here. Okay, so we've determined our intercepts. So now we're going to graph this line using those intercepts. So we're going to graph 7, 0, 1, 2, 3, 4, 5, 6, 7. That's all the way over here on the right. And then 0, negative 3. So 7, 0, you can see it there on the right. And 0, negative 3 puts us down here. And I'm going to draw my line through those points and try to make it as straight as I can. But I don't have a ruler to use with my tablet app here. So now we want to identify one other solution to the line and prove that it's a solution. So we're going to look for a place where these would cross what I would call kind of like a corner here. So I feel about it. Let's see. We can follow our same sort of pattern. So this goes up 3. I meant to grab my red pen here. This goes up 1, 2, 3. And then over 1, 2, 3, 4, 5, 6, 7. If we're following that same pattern going downwards 1, 2, 3, we should also be able to go over 1, 2, 3, 4, 5, 6, 7. And my line pretty much hits right there, but that's because I don't really have a good ruler. So we're going to consider this point right here, which is -7 on the x, and then -6. And we're going to use that point. Now, to prove it's a solution, we're going to plug it in. So we would say -3 and plug in our value for x plus 7 and plug in our value for y is equal to -21. So the x value was -7 and the y value was -6. So we're going to evaluate this and then see what we get. On the left here, -3 times -7 creates +21. And then over here with the 7 times a -6, that's going to be a -42. And is that equal to -21? Well, if we do 21 minus 42, and definitely do that on a calculator if you don't trust me, but yeah, it is going to make -21. And since that is equal to -21, that is our check step. It makes this equation balanced on both sides. That's going to bring us to question 2, which has a couple pieces here. So we want to write each equation in standard form. Now, I didn't cover this entirely in my class, but standard form is ax plus by equals c. And it basically means we have all whole numbers, and our x and y terms are on the left, and our c is on the right. Or our basic numbers are on the right. So let's do that here. And with this first one, I just need to rearrange it a little bit. I have x on the left, but I have the number and I have 14 on the right. So I'm going to subtract 14y from both sides. And that would give me 8x minus 14y equals 26. And this is standard form. For part B, we're going to need to multiply, and I'm going to multiply by everything here by 7. So what that's going to do, if we multiply every single piece here by 7, that's the whole left side and the whole right side, it's going to cancel with the -6/7x term. So we'll still have 7y, but this -6/7, the 7's just going to disappear, and we'll have -6x. And then 12 times 7, I'm going to say that's like 80 or 90 something, but I'm not quite sure, so I'm going to check myself with a calculator. 84. Yeah, that sounds right. So plus 84. Now from here, it's just like question 1, where I just need to move one term over to the appropriate side. And I'm going to move the 6x here because I need to add it to both sides to get rid of it here. And it is common, or it is good practice, to write your terms in alphabetical order. So x should come first, then y, which is a positive number, and over here. So while yes, technically 7y plus 6x would count as an equivalent equation, standard form, the general agreed upon format is that the x term should come first, and that it should always be positive, although your teacher may or may not be more lenient with that one. Okay, so for number C, this one is going to be pretty similar. We're going to multiply by whatever is in the denominator here, and then move our terms over. So I'll do this one in blue, I guess, just to mix things up. So our denominator is 3. We're going to multiply everything here by 3. So we'll have 3y. The 3 is going to cancel, and we'll have left 2x. And then here we'll have -21. So the x term here is on the right-hand side and the y is on the left. I want to move all of my variable terms over to the left, so I'm going to subtract 2x and subtract 2x. Now, like I said, convention tells us we should put our x term first, so negative 2x plus 3y is going to equal negative 21. And your teacher may be okay with you leaving your answer right here. But I am personally of the opinion that the x term should be positive. So when I've got everything rearranged, if my x term is not positive, we would multiply this entire thing by negative 1, which has the effect of just changing every single sign. So if we multiply everything here by negative 1, that is going to create positive 2x, negative 3y, and equal to positive 21. And this is what I would consider the full formal answer. But again, your teacher may be okay with the step above it. I just think it's nicer to have a positive number out front. And that's how I learned it too. So with D, this one's going to be a little bit trickier because I have two different denominators here. If I multiply everything by 5, the 5 will cancel out, but then I have this 2, and the 2 is not going to cancel. So what we can do is multiply by both of those numbers, or both of them put together. So, and by put together, I mean multiplying by 5 and multiplying by 2 is the same as multiplying by 10. So that's the approach I'm going to take here. We're going to take everything here, and it's the same as multiplying it by 5 and by 2, aka 10. So when we distribute these, what's going to happen is that 4, normally just the 5 would cancel out, but the 5 cancels and the 2 stays. So we're going to have 8 and then x. The negative 1 is going to become negative 10 because it has nothing to cancel. And then for our 3 over 2 here, just the 2 part is going to cancel, and we'll have to do still the 5 times the 3. So that'll give us 15y. So that is the tricky part, is multiplying by both of them there. You could do it one at a time, and that would work too. But I like to do them both at once. So now I have to rearrange this so that my variable terms are on the left and my constant term is on the right. I'm going to move the constant term first. That's this 10. So I'm going to add 10 to both sides, which will remove it here from the left. So we'll have 8x equals, and then this is 15y plus 10. So now I'm going to subtract 15y from both sides to put them together. So this would be 8x minus 15y equals 10. And that's our answer here. Okay, for number 3, we have parts A, B, and C, and all of these are in standard form. And our job here is to identify the x and y intercepts and then graph the line using the intercepts. So since I don't have a ton of space, I am not going to show all of the plugging in. I am going to use the cover-up method. So to find my x-intercepts, we plug in 0 for y and find a value for x. And then we would plug in, to find our y value, we'd plug in 0 for x and find a value for y. So if we plugged in a value, well, plugged in 0 for x, we would have negative 4y equals negative 12. If we divide both by negative 4, we're going to get here that the y value should be positive 3. So that's the y-intercept. And then let's plug in y, or 0 for y. Now, I can get rid of the negative that's in front of it. That's okay. 3x is equal to negative 12. When we divide here by positive 3, we're going to end up with negative 4 still left over. I'll erase my scribbles there. And then we're going to graph these pieces. So 0, 3 would put my first point there, and negative 4, 0 puts my next point here. And it'll look like this. And I'll make my other line going this direction line up with it a little better. There we go. So we're going to do the same thing for B and C. If we plugged in I guess I should find the x-intercept first. So I'll leave x alone and plug in 0 for y. We have 2x equals 6. So that means our x value is going to be 3 when we divide both sides by 2. And then if we plug in 0 for x, we get that 3y equals 6, which means we had 0 for x, and then this is going to be 2. So now we can graph these. 3, comma 0 puts me right here on the x-intercept, and 0, comma 2 puts us right there on the y-intercept. Now, please use a ruler to connect these, because if it's asking you to find other, I didn't mean to put a curved line there. If it's asking you to find other points that are on the line, that's going to be really difficult if you don't have a nice straight line. So I'm trying to make this one here as straight as possible in the direction it should go, at least. So it'll look like this. And then we'll do one more here. So we'll plug in 0 for x. That's going to find us the y value first. So negative 3y is negative 6. That's going to give us positive 2. And then if we do the opposite, and we plug in 0 for y, it just actually gives us that x is equal to negative 6. So this should be negative 6, comma 0. So we will have negative 6, comma 0 to start for our x-intercept, and then 0, comma 2 for that one. I'll try to draw this as straight as I can, and it's not going to want to snap into it, so I do have to reposition it. Sorry, I don't have a ruler tool to use on this, but there we go. And those would be our graphs. So that's going to bring us on to the back page. All right, so the back page here. So let's start with question 4. We're going to actually write some equations and then apply these things to it. So Mrs. Underwood is going to buy lunch for all her students from the taco shop. Students can choose either a burrito or a taco. Burritos cost $5 and tacos cost $3, and the total cost is $114. So X is going to represent the number of students who want a burrito, and Y is going to represent the number of students who want a taco. So our job is going to be to write an equation relating the number of burritos and tacos and the total cost. So one of the things I talked with about my class is that a total cost should always be equal to like your number of items. So like number of items, and then multiplied by the price of the one item. And if you have two things, you're going to do that for two different items. They're going to have a price or a cost here. In my head, I think of price as like per one item thing, and a cost or a total cost as like everything. So we're going to set up something like this. So for Mrs. Underwood, she is very generously buying these burritos and tacos. Her total cost is $114. So let's say 114. That's going to be equal to, and now we want to use, they said X to represent everyone who wants a burrito. So we're going to use X to represent the number of those items, and we're going to multiply it by the price, which is $5. So I would write X times $5, but 5X is actually the way we would want to represent that. I know I wrote number of items and price, and technically here it's price times the number of items, but the same idea, it's commutative. And then we're going to add to that the number of students who want a taco and multiply that by the price of the taco. And this is an equation in standard form, although technically I might put the 114 on the right-hand side. So I guess I will actually do that. If we're going to be particular about it, I'll scoot this over and say that that should equal my total price, total cost. So now we want to say if 6 students wanted burritos, then how many students wanted tacos? We can actually plug some numbers in here for that and find that answer. So let's say 6 students wanted burritos, and burritos was X. So this is 5 times 6 plus 3y equals 114. So that's 30. I don't have a lot of space to do this work here, and we might actually be able to just read it from our graph. But if I subtract 30 from both sides, we'd have 3y equals minus 30, 84. And then we would divide both sides of that by 3. I just don't really have a lot of space to show it. So 84 divided by 3 is going to give us 28. So y would be 28. That would be 28 students wanting tacos and only 6 of them want burritos. So we want to graph this line that we created in part A, and we want to label our axes. So they told us that X was students who wanted burritos. Now, this doesn't quite actually fit. I don't really like the way that these graphs are labeled on here because we don't actually go down to 0, 0. It kind of stops at 5. I'm going to relabel this graph and say that this is 0, and this is 5, and 10, and 15, and 20. So I'm scooting everything on this graph here by 5. This would be 25, 30, and then 35. So sorry about that if you realize you can't really start at 0, 0, or that basically your x-axis is cut off a little bit, but no, it's not. If I was doing this using the cover-up method, I would maybe start with something like this and use this to cover up. I would maybe use my finger to actually cover it up if I had paper, but I'm doing this digitally, so I would cover up and say, well, if 3y equals 114, I can divide both sides by 3, and that would give me the y-intercept. It's the same as plugging in that 0. So I am going to label my x-axis here, or my x-intercept, and the y-intercept. I'm going to set these up for myself first. I know that for the x-intercept, I should have the number first and then 0 for y. And for y, we should have 0 and then our number. So let's actually do that division. We're going to do 114 and divide that by 3, because that was the one I had kind of shown you first. Is take this, cover up that, and you get 114. We would divide it by 3, and that number would give us a value for y, which is 38. And then if we covered this up and covered up our 3y, we now have 5x equals 114. So we're going to take 114 and divide it by 5. So 114, if we divide by 5, is not going to give us a nice whole number. It's going to give us 22.8, and it actually doesn't reduce at all. So I'm going to say it's 22.8 with a pen, not with my selection tool. And those are my two intercepts. So on the x-axis, this would be number of burritos. It's technically the number of students who want a burrito, but it's also how many burritos you're going to order. So burritos, and then tacos on our vertical axis, because they said that one should be y. So for burritos, we're going to graph this at 22.8. So 20, 21, 22, it's going to be almost 23. I'm going to put that like right here. Makes the most sense for me on that one. And oh, yeah, that was the x-intercept. And then the y-intercept is at 38. Oh, and that's why maybe it didn't quite show, or why it didn't show the whole thing here. We didn't really have enough space. 38 would be like 36, 37, 38. 38 is going to be a little bit above, like right there. It'll be 3 spaces above. So I'm actually going to draw this line here. Hopefully it'll make a straight line for me. And then make that a little bigger. So it does say identify a solution. We actually found one earlier with the 6 burritos and 28 tacos. So I'm going to double check and see if that one works here. Let's actually see on our graph if it works. So 6 burritos and 28, 6 burritos doesn't quite touch at 28, so I might have to adjust my graph, but that would technically be a solution. I'm going to find a different one here and represent it in context. Let me actually make this graph a little bit better, because I know I should be hitting both of those pieces. This should be 35. I should have a spot here at 22.8. And then we did say that we had one at 6 and at 28. So at 6 and at 28 would be right here. So I wanted to go through all three of these. I'm going to make sure it at least goes through the one on my axis and then the one that we know is a solution, because I think my y-intercept one was slightly off. I can actually erase where I have this stuff here. I was just kind of going through that as an explanation. So I'll erase some of that writing that was in blue and move my point so it's more accurate. So this would be 36, probably 37, and 38, like right there. That does make more sense. Okay, so let's find a new point on here. It looks like maybe it looks like maybe this point right here. And if we go 1, 2, 3, 4, 5, 1, 2, 3, it looks like this point right here would actually be an answer. So I'm going to highlight that point and explain what that means. So that's 24 and it's 23 tacos, because that is the vertical, and then it is 9 burritos. So let's identify that one. 9 burritos and 23 tacos. That means 9 students wanted burritos and 23 wanted tacos. 9 students want burritos and 23 want tacos. That's a potential answer. So I'm actually going to do the arithmetic on that one, make sure it comes out to be that whole number. So let's do 5 times the 9 students who wanted burritos, and then add with that the $3 for the 23 students, and it does come out to 114 exactly. Okay, I just wanted to make sure that I didn't pick one that doesn't actually work out. If you do plug it in, you can see that it is actually part of the solution. So that's going to be our first one there. And the very last question is going to be here, number 5. Helix drama. This one you actually do have the accurate axis here. So Helix drama is selling tickets to their upcoming play, The Twelfth Night. The Black Box Theater can hold up to 75 guests, and they plan on selling out. If they are selling 2 different types of tickets, student and adult tickets, then A says let X represent the number of adult tickets. So immediately I'm going to label my axis here, because they said X represents adult tickets. So I'm going to write adult tickets along my X axis. And Y represents student tickets, so I'm going to write student tickets along the Y axis. Because this graph would not be here if I didn't need to actually do it. So we're going to actually do this graph. Let's write an equation. So this one, they don't tell us any prices, they just tell us what they want to sell. So X is the number of student tickets, and if we add to that the number of adult tickets, which is Y, oh, I'm sorry, X is the adult tickets, Y is the student tickets, I misspoke. If we add those together, they want to sell every seat in the theater. That's what selling out means. So that would be 75 guests. So if they sell 30 adult tickets, how many student tickets can they sell? 30 is x, so this would be 30 plus y equals 75, and that means that y, or the number of student tickets they can sell, would be 45 if we subtracted 30 from both sides. Now let's graph the relationship that we have in part A. So again, if we use our cover-up method, maybe I will use, do I have a little thicker here? Oh yeah, I have like a weird little, oh no, I was thinking it was going to be opaque and I could just use that to cover something up. It's cute, but it's not gonna, you're gonna be able to see through it. So I will just make my little colored in box over here. I'll make it an actual like square, and then I'll color it in. So if we're using this box and we are blocking out one of our answers, we're just going to have that y is equal to 75 for our intercept. And if we blocked out y instead of x, we would have x is equal to 75 as our x-intercept. So both of our intercepts in this case are going to be the same, and they are going to both be 75 because we don't have to divide by anything when the coefficients there are 1. So this here, we would graph both of these at 75. So this is going to be 70, which means 75 would be halfway in between. And the same thing on this one, 70 is halfway right there, so 75 is going to be here. Now, if we graph this, I'm just going to connect my 2 points together, and it's a little wobbly, but we got it to connect. And be sure to label our axes. We did do that. Now they're saying, what is the x-intercept and what does it represent in context? So we'll zoom in here because I'm at the bottom of the page, so it's harder for me to write. So I got to zoom in so I can write smaller. And also, I can't really scroll up. It doesn't let me move things higher up, so it helps with that part too. The x-intercept, we said that our x-intercept was when we have an x value and the y value is 0, and so that was 75 and 0. The y-intercept, I'm going to write down here, of 0 and 75. So what does this represent? This represents they sold, this represents if they sold 75 and X was adult tickets, and no student tickets. Likewise, for the one below it, but swapping that out, the 0, 75 would mean they sold 0 adult tickets and 75 student tickets. So it's just the number of tickets that they sold for each. And I'm pretty sure I have everything now complete for question 5 here. So yeah, they didn't ask us to identify a solution. They just said to identify our axes and describe them. So we're good to go. So that is our homework assignment based around standard form. Hopefully watching the video helped you understand it a little bit better if you were looking for an answer. And yeah, so thank you for watching, and I'll see you in the next video.